Okay, number 7 does not involve, it's a related rate problem which does not involve a volume. Okay, this one says a ladder 20 feet long. Okay, so here's a picture. Here's our ladder. It's 20 feet long. Is leaning against the wall of a house. The base of the ladder, that's right here. Here's the base of the ladder. Is pulled away from the wall, so it's being pulled this way, at the rate of 3 feet per second. All right, so let's label this distance from the bottom of the wall to the base of the ladder. We'll label that x, and from the top of the ladder to the bottom of the wall, we'll label that y. Okay, so the base is being pulled away from the wall at the rate of 3 feet per second. So this is moving away at 3 feet per second. That means x is going to be increasing at the rate of 3 feet per second. So that information is given to us. dx dt is 3. And we're asked how fast is the top moving down, that is the top of the ladder moving down, that is dy dt. What is dy dt? We're being asked what is dy dt when the base of the ladder is A, 5 feet from the wall and B, 15 feet from the wall. So we're asked dy dt equals question mark when A, x equal 5 and B, x equal 15. All right, so we're going to first write down some equation that involves x and y. So we're going to use the Pythagorean theorem, since this is, we're assuming this is a right angle over here. Okay, so we have x squared plus y squared is equal to 20 squared, which is 400. So that's our equation. Now it only involves 2 variables, so we don't have the eliminate step here. And we'll go straight to the differentiate. We'll differentiate, so we'll get an equation involving dx dt and dy dt. All right, so let's do that. So here we have 2x dx dt plus 2y dy dt is equal to the derivative of 400. Derivative of a constant is 0. Let's divide this equation by 2 just to simplify it. All right, so now we have an equation relating dx dt and dy dt. Okay. So we're ready to answer the question. We're ready to substitute. Let's do the substitute step. So first we're going to substitute x equal 5. We have x equal 5 and x equal 15. First x equal 5. All right, into this equation, x dx dt plus y dy dt. So here we'll put the 5. We're told that dx dt is 3. So we'll substitute 3 here. We want to figure out what dy dt is when x equals 5. So we must substitute something for y as well. Well, we can use the Pythagorean theorem again. We still have that relationship x squared plus y squared equal 400. So we can figure out what y is when x equals 5. So what we're going to do now is use this we're going to find y when x equals 5, just to get rid of y from this equation. We're still in the substitute step. All right, so let's do that. So we have when x equals 5, so we have 5 squared plus y squared equal 400. 25 plus y squared equal 400. Subtract 25. We have y squared is equal to 375. So y is the square root of 375. So that goes right there. Okay, so we're going to have 5 times 3, that's 15, plus square root 375 dy dt equals 0. So solve that, and we have dy dt is equal to minus 15 over the square root of 375. And that would be feet per second. Okay, so that's how fast the top is going down when x is equal to 5. And we can do the same sort of thing now when x is equal to 15. Okay, so let's do that. So we have x dx dt plus y dy dt equals 0. Use the Pythagorean theorem to figure out what y is. So this time we want to find y when x equals 15. Okay, so we have x squared, that this time it's 15 squared, plus y squared equals 400, 225 plus y squared equals 400, y squared is 175, and y is square root 175. Okay. So there, we'll substitute the 15 here. Dx dt is still 3. Y is square root 175. Okay, so solving that, we have, this is a 45 over here, and we have 45 plus square root 175. Sorry, this is this should be dy dt. dy dt equals 0. So that would be dy dt is equal to minus 45 divided by square root 175. Again, feet per second. Notice in both cases dy dt is negative, and that's because y is decreasing. Remember the picture? As the ladder is being pulled out, y is getting smaller, so it makes sense that dy dt should be negative because y is decreasing. Number 8 says that a trough, this is a picture of a trough, it's what an animal drinks from. A trough is 12 feet long, okay, that's 12 feet over here, and 4 feet across the top, 4 feet here. Its ends are isosceles triangles, so this right here, that's an isosceles triangle, with an altitude of 4 feet, so that's the height over there is 4 feet. And here it says water is pumped into the trough at the rate of 3 cubic feet per minute. All right, so we're told that means that dV dt is equal to 3. The volume is increasing at that rate. Okay, how fast is the water level rising when it is 2 feet deep? Okay, so we need some variables over here. Here's the water. We're interested in the volume of the water. This volume refers to the volume of the water at the bottom. All right, so we need some variables. So let's call this the height of the water. Put an h over there. And let's say this side of the triangle, let's call that h. Sorry, let's call that x. So we're asked how fast is the water level rising when it is 2 feet deep. So we want to know what is dH dt when h equals 2. So first we need a formula for the volume of this trough. So the volume is going to be the area of the triangle, the area of this triangle. Sorry, we want a formula for the volume of the water. So it'll be the area of that triangle times 12 feet. All right, so let's write that down. So the volume is going to be the area of the triangle. Remember, area of the triangle is 1/2 base times height. So that'll be 1/2 x times h. And then multiply the area of that triangle through by 12. So our volume formula, divide 2 into 12, is 6xh. All right, so that's the volume. Okay, and notice that we do have 1, 2, 3 variables, so we will be eliminating. Which should we eliminate? Well, we're interested in V and H, so we're going to eliminate X. All right, so now we're going to do the eliminate step. Okay, remember, we want to eliminate X. Well, I'm looking for some relationship between X and H so we can eliminate X. All right, and like in the previous cone problem, we're going to have these similar triangles. We have the big triangle of the outer trough and then the little triangle that is this face of the water. Okay, and so we're going to have similar triangles once again. So let me just look at those triangles here. And the big triangle has base 4 and the little triangle has base x. The big triangle has height 4 and the little triangle has height that's h. All right, so we have this relationship. This is h right here. Okay, so we have this relationship. We can say 4 is to x. 4 is to x as this 4 again as 4 is to h. All right, so we're just pairing up the sides that correspond. Like this side corresponds to this side, 4 is to x, and this altitude corresponds to the altitude h, 4 is to h. So if you just cross multiply and everything, you end up with x equal h. All right, so we would get 4x equal 4h. So we end up with x equal h. So it turns out that x and h are equal, and that's the little relationship that we need for our eliminate step. All right, so again, we want to eliminate x, so volume equal 6x h. We're just going to eliminate x. X is equal to h, so put an h there. And our simplified volume is volume equals 6h squared. So we're done with our eliminate step, and now we're up to our substitute step. Sorry, not our substitute step, we're up to our differentiate step. It's always eliminate, differentiate, then substitute. Now we're up to our differentiate step. We didn't do that yet. Okay, so we need an equation that relates dv dt and dh dt, so we'll get that by differentiating. So let's do that. So we have dv dt is equal to 6 times 2h dh dt. Okay, so that is dv dt is equal to 12h dh dt. Okay, now we're ready for our substituting. And let's see, we were told that dv excuse me, we were told that dv dt is equal to 3, and we want to find dh dt when h is equal to 2. So those are the values we're going to substitute. So 3 goes here, and we want to know dh dt when h is equal to 2, so a 2 goes there. So we have 3 is equal to 12 times 2, that's 24 dh dt. And just divide 3 over 24 is equal to dh dt. Okay, so that's 1/8. And the units are feet per minute. So the height when h is 2, the height of the water is increasing at 1/8 feet per minute.